Hi everyone, and welcome back to the 360DigiTMG's Domain Analytics program. So it is the fifth day of Domain Analytics since last 4 days, last four sessions. We've been discussing about the banking, insurance, and analytics. So what are the things that we can automate when it comes to banking and insurance using machine learning and AI? So we have seen various examples and what are the applications we'll be having like that we have seen in the very first day. If you haven't gone through those, in that case, I highly recommend you guys to go through those videos first. And then you can see the very first application. At the very first day, we have discussed applications of machine learning and AI when it comes to banking and insurance. And then we have seen in order to do the data science projects, irrespective of any domain, whether it is banking, whether it is insurance, healthcare, agriculture, HR, various domains will be having, irrespective of any domain. In order to improve the accuracy of the model, we have to go through one standard process. So that we have called as CRISP MLQ. Cross-industry standard process, machine learning quality assurance. So what are the phases we'll be having? And what is that hierarchy? What is that sequence that we have to follow in order to increase the accuracy of the model or data science project? So that we have in detail discussed. So please go through those videos as well. First phase, we will be having business understanding and data understanding, and then we have pre-processing, and then we have model building, and then we have evaluation. So various phases will be having it in each and every phase. What we will be doing in detail, we have discussed. I highly recommend you guys to go through it. And we have seen supervised models, and we have seen unsupervised models. So what exactly the supervised model is and what exactly the unsupervised model is, we have discussed. If you haven't have an idea regarding that, I'll briefly go through it since we will be discussing today supervised model. One of those supervised model, that is K nearest neighbor. So what exactly the supervised model we will be discussing in a minute. And on third day, so we have discussed in the third day, what are the pre-processing techniques we'll be having. So raw form of the data that we won't be using directly to the machine learning model. Instead, we will be doing the pre-processing. There will be so many anomalies present in the data. So to avoid those or to clean the data, we have various techniques like outlier treatment we'll be having, encoding techniques we have, and duplication removal also we will be having. Duplication removal, like that we have various techniques that we can do to remove those anomalies, the raw data, whatever the raw data will be having, the anomalies that are present in the raw data, we will be removing these using the various techniques we'll be having that we have discussed on the third day. Once the pre-processing is done, so the model building part, that is something we will be doing right after the pre-processing. So once it is done, based on the which kind of model you are going with, whether supervised or unsupervised. So when it comes to supervised, what we'll be having, if you have a data with the label means output. Labeled data, we'll be calling it as labeled data or data with the output. So if we have a labeled data, in that case, we will be going with the supervised. And if you don't have a labeled data, in that case, we will be going with the unsupervised. So what happens? in the unsupervised, whatever the unlabeled data you will be having, simply will pass to the unsupervised learning, and based on the patterns that we have in the data, we will be forming the clusters. Various clusters will be forming. It is not just based on various data similarities that are present in the data, will simply form various groups, various clusters, you can say, that will be forming. This is all about the unsupervised. Yesterday, in the fourth session, we have seen how the data will be clustered, how the unsupervised learning will be happening, that we have in detail, we have observed, taking one use case scenario. We have taken one use case and then we have observed it. Similar to that, we have supervised. So when we are talking about the supervised data, which is having the output, or you can say labeled data. We have taken one example, it's the COVID data. We will be having features, that is X1, X2. These are like cough, whether that particular person may have a cough or not, fever or not, and the various other. And then we will be deciding the output, whether person has a COVID or not, positive, negative. So this we will be calling it as, based on these features, these inputs are independent variables. We are deciding that particular person or that particular individual person having the COVID or not. So this will be considering as output or labeled data. When you have this, we will be going with supervised, under the supervision of something. What is that? That is an output. So in supervised, we have various algorithms. In supervised, various algorithms will be having, like KNN, decision tree, neighbors, like that. Various algorithms will be having. Among these, we will be first we will be discussing the KNN, K nearest neighbor. Nearest neighbor. Why we will be calling it as nearest neighbor? You will come to know in a few minutes. So this is very first supervised learning, and we will be taking one use case scenario, and we'll try to understand first how this K nearest neighbor will be working, and how this will be implemented when it comes to real-time scenarios. And like that, we will be taking one use case scenario. We'll try to implement K nearest neighbor algorithm, and we'll see how these will be getting, how these will come up with the various results you can say. Before starting that, we'll see what is the agenda for today. Nearest neighbor classifier. Why it is called as a nearest neighbor classifier? What is the mathematics behind this? Behind the classification, on which base it will be doing the classification, or which base it will be doing the regression. So we can use the K nearest neighbor for classification and the regression. For both, we can use K nearest neighbor. K nearest neighbor, what exactly it is, we'll try to understand the mathematics. A classifier controlling the complexity of the KNN. When you have KNN, so every algorithm will be having some tunings, parameter tuning you can call. At what parameter the algorithm will be performing good. So we have some parameters here. We will be having K value. What exactly the K value? We'll be looking into it. And Euclidean distance, how this Euclidean distance will be helpful to determine the one output. That could be regression output, that could be classification. how it will be classifying, how it will be coming up with the regression output, that is continuous output. We'll see now. Before that, I hope you guys have an idea about the classification and regression. Classification and regression. What happens in classification? What happens in regression? When we will be going with classification, when we will be going with regression. In classification, if output, so we have discussed, right, the labeled data or labeled data. If output or labeled data is in the form of discrete means 1 or 0, like true or false. Since we have the COVID positive or COVID negative, so we have just two. This is one class and this is one class, and this is one class and this is one class. True, false, it is also one class, it is one class. When you have labeled data in discrete form or categorical form, in that case we will be going with classification. In that case we will be going with classification. If the output is in continuous form, continuous means decimal form, like 5 and 6, all the salary prediction will be having it 50,000, 50,000 and 5, some other value. Insurance is about 47,500 and 35, something like that. We have various values, right? If you have outputs in this form, in decimal form, in that case we will be going with the regression. So this is a difference in between classification and regression. In both cases, in both classification and regression cases, we can use KNN. So we'll try to understand how this KNN algorithm will be working. What is the mathematics behind that KNN classification algorithm? I hope you have clear understanding now what exactly the classification is and what is the regression. What is the supervised and what is the unsupervised? When we will be going with the supervised, when we will be going with the unsupervised one, when we will be going with classification, when we will be going with regression. This is, I hope it is clear. Now we'll get into the K nearest neighbor algorithm mathematics or behind what exactly happens. Like we have already discussed what exactly the CRISP-MLQ method is. Same, the very first one, like we have already discussed multiple times, business and data understanding. The very first phase, here you can see business understanding first, very important. What exactly the statement is, what are the things that we have to achieve from that problem statement. Once it is done, we will be having the data. You have to understand the data is all the data that you are taking, or the features you are considering, are they satisfying the business objective? In order to predict something, when you are having some business objective, in that case, you might be having an understanding which features you have to take up, right? So whatever the data that you are taking, are they enough to do the prediction? So whatever the output prediction that we will be doing. So we have to thoroughly undergo those features, understand those features. Once it is done, then we will be going with data preparation. In data preparation, anomalies. It is the raw data, whatever the data that we will be getting, raw data. So whatever the raw data we will be having, first we need to pre-process. Once pre-processing is done, then we will be feeding to the model. And if the model is not enough, in that case, we'll go back to the pre-processing. And if there is something that is missing, some pre-processing haven't done properly, again, we'll be doing the pre-processing. And once it is done, we'll go back to the model building. So it is continuous process. If you are doing some mistakes, in that case, we go back and do the pre-processing, again do the model building. Once it is done, we'll be doing the testing. Model building we'll be having it. For that, we will be doing the testing. If it is working fine and giving the good results, it's fine. If it is not, we'll go back to the business understanding. So if it is not giving the good results, in that case, whatever the problem statement we haven't understand properly, or we haven't taken the good features. So what exactly the output is? Let's say salary prediction we are doing. So how much? Let's say it is HR analytics. In this, we will be doing all this. Or when it comes to insurance prediction, I will be taking this use case at the end. In order to do the prediction of this particular insurance, we have to go through the various features, various input features I'm talking about. We have to consider all those things. When you have India, let's say India. So yeah, this is India, let's say. Sorry about it, I joined. So here, north, south, east, west and east. So whatever the weather conditions we will be having here, you will be finding here. Whatever the condition that you will be having here, you won't find here. So all the weather conditions and the concerns over the people, maybe in Assam. So every now and then, every year, there are so many floods. Will be there. In that case, the insurance that we are providing here, the terms and conditions related to this particular area will be very different when it comes to this particular area. And whatever the terms and conditions that you are using here, when it comes to central India, in that case, for them, it is completely different. So like that, area-wise, it will vary what kind of terms and conditions you will be having when it comes to insurance. It is very different. So what kind of features we are supposed to consider when it comes to each and every area, that also varies. So when you are doing the business understanding, you have to keep all these things in the mind. So when it comes to here, there are so many earthquakes every now and then will be happening, and there is slides, the rock slides will be happening. Uttarakhand, and here in Kashmir, we will be having snowfall. In that case, also things get worse. So various conditions will be having when it comes to various locations. So you have to consider all those things. Based on that, you have to come up with the features. When you come up with features, whatever the feature that you are taking, is it giving good result, or we need to consider some other features? So that all will be decided when it comes to business understanding. So if you are taking the exact features, in that case, yeah, model will be giving you good results. But if it is not, in that case, you have to go back to the business understanding. You have to go through the problem statement one more time, and you have to analyze it, and you have to research what kind of features we need to add more. Similar, let's say HR, you haven't considered the experience just based on the skills and some other age and other. We are doing the prediction. In that case, do you think this model will give you good accuracy? No, it is absolutely necessary. Experience is something that will be giving, that we will be giving high priority, right? So you need to have good features that will give you maximum information. So that is something we will be looking into. So once it is done, model evaluation is done, model testing and evaluation is done. If it is giving good results, in that case, we'll do the deployment. Once the deployment is done, we will be doing the monitoring and maintenance. What happens in monitoring and maintenance? How good in deployment in real time, how our model is performed. So that we will be doing monitoring using the monitoring and maintenance. If our model is performing not well for some data, so what exactly the data is? So we'll be making one library of the data, and we'll try to retrain the machine learning model with the data that is not working. And every now and then trend will be changing, right? Every now and then trend will be changing. So data also should change. Whatever the condition that you have taken till now, for now, the same, you can't rely on the same features when it comes to insurance. Previously, pre-COVID era, we don't have anything, something like pre-COVID. So we don't need to mention about that COVID when you have the COVID era. But when it started, so it is a great concern. You can't really give insurance. I mean, when it comes to insurance companies, if they include COVID in that case, you might have maximum claims. In that case, our insurance company might go bankrupt. So they have so many, insurance companies say that they have added terms and conditions, COVID excluded, or specifically for COVID, there are so many insurance launch. So like that, every now and then they will be changing. I mean, the trend will be changing. Nowadays, I mean, COVID is a concern. Maybe in future there might be something else. So it is completely depends on what is the trend presently, what kind of diseases are being a great concern. Based on that, we will be changing the data every now and then. So these are the crisp MLQ very briefly. So what are the features we have to consider, how this whole data science project works when it comes to insurance data. Insurance and banking, even banking the same. So this is the project management methodology, that is crisp MLQ, cross industry standard process, machine learning quality assurance. Yeah, like we have discussed yesterday, that is unsupervised. Like we have discussed yesterday, unsupervised. Similar to the process, similar to that process, we have supervised process. So what we will be doing in supervised, we'll go through it. We have already gone through it. Anyway, I'll be going through very briefly. See here, training and validation. So the main data, historical data, we'll be having the whole data. The main, whatever the data that we have. After pre-processing, we will be simply splitting the data into train and test. So training the data set and the validation, you can also call as a test. Whatever the data that you will be having. So how much we have to give for the train, how much we have to give for the test. So it is completely based on the data set you will be having. Let's say if you have 1 million data, that means records, entries I'm talking about. If you have 1 million, in that case, you can give 90% data to training and 10% data to test. Since we have enough, 90% data means 900,000. For that, I will be giving for train, and 100,000 I'm giving for test. It is more than enough to test that particular. So like that, based on the data set, how much data set you will be having, we will be splitting the data into train and test. Let's say I have 100,000 data. In that case, I might not be going with 90% for training. Instead, I might going with 80% for train and 20% for test. So it is completely, it is not like we will be taking always 80% for the train and 20% for the test. Based on the data or the records we have, we will be splitting the data into train and test. So once it is split into the train and test, the train data set, we will be using the train data set and we'll be using the machine learning model. So what machine learning model will be doing here, whatever the data you have, so it will go through it, and that is a record means pattern. It will understand the patterns. So various patterns we will be having when it comes to classification or regression. Various patterns we will be having. Based on those patterns, it will come up with the one new logic. So that logic we will be having here, and for that we'll be passing the validation data or test data to check how good it is performing. So yeah, we will be using the various mathematical equations in order to come up with that particular logic, and we'll be passing the test data to check how good our model is predicting. So whatever the values that we got, we'll be saving that, and then we'll be evaluating how good our model is performing. So new data and whatever the predicted data will be having, machine learning model will be having, we'll be passing through, and then we'll check predicted values and actual values that we'll be having. So if it is a classification, in that case, we will be using the confusion matrix. Confusion matrix or cross table to check how many misclassification we have done, how many correct classification we have done. So that we will be checking. Based on that, we will be deciding whether our model is good model or not. So that phase we will be calling as evaluation, model evaluation. If it is having the good accuracy, in that case, great, we'll be going with that particular model only. If it is not having good accuracy, in that case, we'll try to do the hyperparameter tunings or parameter tunings you can call. In parameter tunings, each and every model will be having some parameters. When it comes to K, NN, we have parameter called K. So what exactly that we will be discussing in a minute. So this is what happens when it comes to supervised. So now you understood, right, how supervised model will be working. So we'll try to understand in real life how the KNN algorithm will be working. Let's say it is a classification of image data. How it will be classifying that input based on what? So you can see that how many classes we'll be having here. So here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Overall 10 classes we have. That is what multi-class classification. Multiple classes we have, right? Multi-class classification. We have multi-class classification. So what, see, it is a data frame. If new data, we have trained the data set, we have trained the machine learning model. Training examples, we have trained the machine learning model based on this data. This data we have used to train the machine learning model. Let's say I have given value 4. That value 4 in various ways basically we can write, right? Some people will write something like that, some people write something like that, some people write like this. So various ways we can write that 4. And when it comes to 7, some people will write like this, some people write like this. Various ways we can write that 7, right? So when I am giving a new input, I want that to be categorized, whether it is which class it will be belonging to. So when you are giving the new data, in that case, what will K-NN algorithm will do? So whatever the incoming data will be having, it will try to understand how it is looking like. Do we have any data that is looking exactly like this? So it will compare with each and everything. It will compare with each and every data. So it will go through each and every data. Is it looking like any data that is present in our database? How nearly it is, how closely it is looking like. So it will go through all, and based on that, based on the similarity only, it will find out that similarity, whichever the, let's say, it will be looking like 10% similar to the 4, this one, and 4, it will be looking like 5% similar to that. 3, it is just 5%, it is looking like this, something like that. It will go through each and every data, and then it will coming up with here 4%, it is looking like 90% similar to that. So among all these, which one is most similar to this? So 90%. So this one is looking like this. So now it will classify this as 4. If you give input is equal to 6, in that case, again, it will check with each and every data, and whichever it belongs to, it will simply print saying that it is a 6. So this is what happens when it comes to KNN. What exactly it will do? Whatever the new data that you are giving, will go through the whole data set, and wherever you are having the closeness, where exactly we'll be having the closest value, it will result in the output saying that it belongs to this class. So this is what happens when it comes to image data. So when it comes to in classes, we have various classes, right? When you have various other data set, in that case, how it will be performing, we'll see in detail. Okay. So here you can see the data. These other classes, we have this one is one class, it is one class, it is one more class. Overall, how many classes will be having? 3 classes we have. 3 classes will be having. When you are introducing, so what exactly these classes are? Orange. So this data frame will be having it. This is data set. A data point, you can say data point and data point, data point, data point. Each and every data point having its features. Features in the sense, what kind of characteristics it will be having. Let's say we will be taking that in the next slide. This one will be having background features, and this also will be having various features. Whatever the features we are considering to classify this as a yellow, and classify this as a green, and classify this as a orange, that features will be having with this data points as well. So what it will do, it will try to find out the similarities with each and every data. It will try to find out the similarities. How? Based on the Euclidean distance. It will try to find out, you can see here, it will find out the distance between each and every data point. Whichever the data is very near to this data point, whichever the data that is very near to this data point, this becomes that class. Let's say this is the shortest distance will be having, that case will become orange class, not orange, is yellow class. If it is having the shortest distance in between the green and this data point, in that case it will become the green class. If it is having shortest distance with orange, in that case it will become orange class. Whichever the nearest one it will be having, it will become that class. So this is what happens. So it will be finding. So we can see here neighbors. Yellow, we have 2.4 and 2.1 and 2.4. And when it comes to green, it is having 3.1 and orange, it will be having 4.5. On these, which one is having the least distance? In that case, it is 2.1, that is yellow. So what happens? It will become yellow. Just based on the distance only, we are not, doing anything different based on the distance. What exactly the distance is will be called as Euclidean. So how we'll be finding out the distance? X2 minus x1 whole square plus y2 minus y1. So when you have just 2 points, in that case, we'll be using that. Otherwise, it will keep going on. When you have 2 data points, how we will be finding the distance? Similar to that, we will be finding the Euclidean distance. But various data points we will be having, so it will keep going from. So this distance will be calculating based on this Euclidean distance. Whichever the shortest distance we will be having will convert the data point into that class. So here it will become yellow class. So like that, it will be doing the finding the distance, and it will become that class. We'll see one example. In that case, you might be getting the idea. Yeah. Okay. Before that, we'll go through how KNN will be working and what exactly the nearest neighbor means. The KNN working can be explained on the basis of below algorithm. Select the number of K of the neighbor. So first we will be selecting the K value. K is equal to 2, K is equal to 3, 4, something various values will be having. So how when you are giving the K value, how the algorithm will be performing, that we will see using the visualization. Calculate the Euclidean distance of K number of neighbors. Let's say I have given K is equal to 2. So it will be considering just 2. And it will try to find out the distance between, shortest distance between just 2. It will be calculating, let's say new data point we have introduced, right? We have built one machine learning model and we have introduced new data points. When you are introducing new data points, we have to classify which class it belongs to. In order to decide that, we will be finding out distance between each and every data point. And if K value we are considering 2, in that case, we will be taking just shortest 2 distances. Based on that, we will be deciding whether which class that belongs to. So how we will be selecting that, we will be seeing in a minute. Take K nearest neighbor as per the calculated Euclidean distance. Among these K neighbors, count the number of data points in each category and assign the new data points to the category for which the number of neighbors is maximum or model is ready. So we'll see that. While choosing the K value, keep following these things in mind. If K is equal to 1, the classes are divided into regions and the query records belong to a class according to the region. So we are not supposed to take the K value is equal to 1. Choose odd values of K for a 2-class problem. If you are going with the 2-class binary classification, in that case, better if you take K value is equal to odd. Let's say K is equal to 3, K is equal to 5, K is equal to 7, something like that. Better if you take those odd values. Why we need to take those odd values only? Why can't we take the even values? That is also we will discuss. K must not be multiple of the number of classes. K not equal to 9. Where n is the number of classes, I is equal to 1, 2, 3. Why it is, they will be discussing. You can understand when you go through this visualization. Let's say COVID, in order to understand the data points, we'll take COVID data. Let's say I have features cough, that is one feature, and body pain, that is one more feature, and cold, one more feature, and fever, one more feature, and then status. So if you have a cough and body pain, cold, fever, in that case, I might be saying you will be having COVID positive. Let's say you don't have a cough, you don't have body pain, you might have a cold and you don't have a fever. In that case, it might be saying that COVID negative. So these are what input features. Based on this input feature, we are deciding it is a COVID positive or COVID negative. And let's say this COVID positive, I'll be considering as yellow, and COVID negative, I'll be considering as blue. So we have two classes, right? Sorry, pink. It is pink. I'm sorry. Okay, pink. We are considering for the positive, and when it comes to blue, we are considering as negative. Red is pink is positive, and blue is negative. In order to say this is the COVID negative, we have some features. So they same features. And not just two records we'll be having, like multiple thousands of records we'll be having. So these are all records only. Each and every record, based on that, we have labels. Blue labels, that means we don't have the COVID. That particular person doesn't have a COVID. 1%, 2%, 3%, and their respective features will be having various data points and their respective features. So this is the one feature, and it will be having these features, these data points, it will be having these features. Based on that, we are saying that this is a COVID negative. Sorry, it is a COVID positive. Based on, for this also we have same features. Cough, body pain, cold, like that, all the features will be having. Based on that, we will be saying it is a COVID negative. Like that, we have blue, and then we have pink. Pink is a COVID positive and blue is COVID negative. So each and every data point will be having features. Each and every data point will be having features. Now I have introduced one data point. So first, I haven't given this any color. It is a new data point. Let's say, okay, yeah. I have introduced one new data point. It doesn't have any color at the beginning, a new data point. When you are introducing a new data point, it will be having features, same features. What data point? These data points will be having same features will be having. How can we decide which class this feature is belongs to, or which class this data point belongs to? The new data point that we have introduced. To decide which class it belongs to, first we have to find out the distance. We have to find out how similar this data point with respect to others. If I am considering k is equal to just 1, so I will be finding out the distance with each and every data point. This is one data point, this is one data point. Each and every data point, I will be finding the distance between each and every data point. Since I have mentioned k is equal to just 1, shortest distance I will be taking. Among these, all these, which is the shortest distance we have? This one. This one will be the shortest distance, right? Now, what will be doing? Whatever the characteristics it will be having, same characteristics will be having, since the similar distance or shortest distance will be having. Based on the shortest distance, we will be finding the similarity. What is the shortest distance? We're using what? Euclidean distance. So we'll find out the distance between each and every data point. If it is k is equal to just 1, we will be considering the shortest distance. Just one shortest distance will be considering. Based on that, we will be deciding whether it belongs to blue or pink. Since k is equal to 1, which is the shortest we have? We have pink. So it will become that class. So it will become pink. We have find out the distance between each and every data point, but it is the shortest distance and it is similar. It is having the pink. In that case, the whole this data point become P. So now what it is a COVID positive. Whatever the data that you have taken, the new data that is came up, so it is become a positive. Let's say the same thing when you are finding out. So what happens when k is equal to 2? In that case, how it will be deciding? When k is equal to 2. Same way that we have done when it comes to k is equal to 1, it will be finding out the distance between each and every data point. All the data points will be finding distance between each and every data point. It will be finding the distance between each and every data point. Since k is equal to 2, it will be considering just two shortest two distances. Among first, it will calculate the distance, and among those, whichever the shortest distance will be having, it will consider those only. Based on that, it will decide whether it belongs to the COVID positive or COVID negative. So here we have found out that among these two classes we have. So it is the shortest one and it is the second shortest one. So it is a blue and it is a pink. Among these, it is the shortest one. So it will become again, it is a pink. So what if we have k is equal to 3? Similar to what we have done for k is equal to, we will be considering 3 shortest distances. Instead of just 2, now we will be considering this 3 shortest distance, how it will done. 1, in that case, whatever the shortest distance will be having, it will become that class. And if it is 2, in that case, also we will be checking among those which is having the shortest distance, in that case it will become, because we have various, I mean different. It is blue, we have pink. If we are both pink, in that case it will become pink. If it is both blue, in that case it will become blue. Since we have one pink and one blue, that is COVID negative, COVID positive and COVID negative. So among these, whichever the shortest one will be having, it will simply go with that. So if you see here now, we have k is equal to 3 now. So we are considering the shortest distance, 3 shortest distance we are considering. Same, it is a new data point that I have introduced, and we will be finding out the distance between each and every data point. And among these, we will be considering the shortest, 3 shortest distance we will be considering. 3 shortest distances we will be considering. So once we have considered those 3 shortest distances, among those, which is the majority class? Blue is the majority class and pink is the least majority. Among these, whichever the majority class we will be having. So among those, we will be considering that as the, I mean, this is a new data point. 3 we have considered. Among this, whichever the majority class is. So blue is the majority class, right? So it will become blue. It will become blue. Like that, if you are considering the k is equal to 3, if you are considering k is equal to 5, k is equal to 7. If we have k is equal to 3, 5, 7, in that case, we can easily able to classify. If we have k is equal to 2 and 2 data points we have, here blue and here pink. If both are exactly the same distance, in that case, the algorithm will be in dilemma. So it will happen very rarely. Still, it will happen very rarely. Still, if it is the case, in that case, how will we handling that? To avoid that, we will be simply going with k is equal to 3, 5, 7, something like that. Yeah, it happens very rarely, but still to avoid that, we will be going with this. K is equal to 3, 5. If you see k is equal to 3, in that case, 2 are majority we have, 1 is pink. So whatever the majority class will be having, will simply make that new data point as a based on that class. So it belongs to blue now. It is blue. Something like that will be deciding. So it is when k is equal to 3. What happens when we are using another? K is equal to k is equal to 8. When you are using the k is equal to 8, in that case, how the algorithm will do? Say it is a new data that you have introduced. It will find out the distance between each and every data point, and whatever the classes will be having among those 8 shortest paths will be taking. These are the 8 shortest paths. Among these, which is the majority class that we have to find out? Blue 1, 2, 3. And when it comes to pink, 1, 2, 3, 4, 5. So among these, pink is the majority class, so it will become pink. That is COVID positive. So like that, whatever the new data point that we have, based on the distance, that is Euclidean distance, we will be finding out the similarity, and we will be deciding which class that particular data point belongs to. Like that, we will be deciding which one it belongs to. We'll take one use case. In that case, you might understand clearly. So which is the k value? Well, how can I come up with a conclusion saying that it is a k value I have to take? Which k value finally have to take? Like we have taken k is equal to 3, 5, 7, 8. So like that, how long we should keep going? So to decide that, we will be having one chart called controlling complexity of the K-inian algorithm. Let's say these are the k is equal to 2 or 3, you can say 5, 7, 9, 11, 13, 15, 17, 19, 20 or something like that we will be having. It is keep going. And this is the accuracy of the model. So when you increase the k value, when training accuracy, it is keep increasing. Training accuracy, it is completely based on the trained data. The more data, in that case, better training accuracy will be getting. So most number of data, if you are feeding the most number of data, in that case, it will keep increasing. When you have less data, indeed, it is having the less accuracy. If it is increasing if you are increasing that particular data, in that case, it will keep increasing. But when it comes to validation or test accuracy, it is not the case. It will be increasing with respect to the data, but at one point, it will reach the maximum and then it will start decreasing. At one point, with respect to the k value, it is keep increasing. At one point, it will reach maximum and then it will start decreasing. So we have to find out. You can see here, less training data, less training accuracy. Here, accuracy and less test accuracy. This will be called as underfitting. When training accuracy and the testing accuracy are less, in that case, we will be calling it as underfitting. If training accuracy is high, and testing accuracy is low, in that case, we will be calling it as overfitting. Or we can call it as variance, or variance. And here we will be calling it as bias. We should find one sweet spot where training as well as testing accuracy are almost equal or exactly equal. That point we will be calling it as bias variance trade-off. That point will be calling it as bias variance trade-off. So we have to choose k values in such a way that both training as well as testing accuracies are exactly similar or near similar. So that we will be calling it as sweet spot or bias variance trade-off. So like that, we will be deciding how much k values we should take. So I hope you have understood what exactly the k values and how we will be controlling the k-inian algorithm using the k value. So this is how we will be coming up with the best model or best accuracy to avoid the overfitting and the underfitting. So here we have a use case scenario. Among those, ingredient, sweetness, crunch. So these are the features. So ingredient we have sweetness and crunchiness and food type. Whether it is fruit, let's take me. Yeah. Feature 1 and feature 2, input feature we are talking about. Feature 2 and feature 3. Based on these features, we have to decide whether it belongs to which type. These are the classes. Fruit, we have one class, protein, two class, and vegetable. Three classes will be having based on what? These features. So this is the record, you can say, or individual, you can say, apple, sweetness and crunchiness. Just two features will be having. It is not a feature. It is just one record, or you can simply say experiment. Apple, what is the feature? Sweetness, how much we have? Sweetness, how much crunchiness we have? Based on that, we have to classify it as fruit or protein or vegetable. Bacon, 1, 4. It is the sweetness and it is a crunchiness. Based on that, how much, which class it belongs to. Banana, 10 and 1. It is a sweetness and it is crunchiness, which it belongs. So this is one pattern. This is one pattern to decide that is a fruit. It is one pattern. It is one more pattern in order to decide this is a vegetable. And this is one pattern and this is one pattern in order to decide that it is a protein. Like that, we have various patterns based on that. So this is the features. So let's say I am introducing new data points. Apple, bacon, we have banana, carrot, celery, and cheese we have. Let's say I am introducing one data point, that is tomato. So when you are introducing the new data points, whatever the features it will be having, we will be having the features for this as well, right? Let's say sweetness, some values we have, crunchiness, some values will be having. New data point, what we will be doing, whatever the values we have, let's say 6, 4 or 4, 6, whatever the value we will be having. What we will be doing, we have to find out the distance. What is that? X2 minus x1 whole square plus y2 minus y1 whole square. Since here we have just two features, so you can go with this formula only. It is, we'll be calling it as Euclidean distance. We'll find out the distance between each and every data point. If k is equal to 1, whichever the shortest one, shortest distance we'll be having among these. We'll find out the distance with apple, we'll find out the distance tomato, right? Distance with apple, distance with bacon, distance with banana, distance with carrot, distance with celery, distance with cheese. We'll be finding a distance between each and every one. Wherever you are getting the least value, if k is equal to 1, in that case, tomato becomes that particular class. Let's say it is having the least distance with the carrot or least distance with the celery. In that case, it will become vegetable. If it is having the least distance with cheese, in that case, it will protein. It will be having the least distance with apple. In that case, it will become fruit. If we are considering the k is equal to 2, in that case, we will be considering the shortest distance. If both those classes or the shortest distance will be having right near to this, both belong to the fruit or protein, any one of this, in that case, it will become that. If it is various, in that case, again, we will be checking which feature, having the shortest one, which class it is the shortest one. Among those, we will be deciding which it is belongs to. Like that, we will be deciding which it belongs to. So you can see here, based on the feature, we have given here a very limited. You can see various. Let us have celery, carrot, cucumber, green bean, apple, pear. So based on those category, we have various classes: vegetable, proteins, and fruits. Vegetable, fruits, and proteins. And then we have introduced one tomato. So when you are, so each and every will be having same features, right? We have crunchiness and sweetness. Each and every data point having this feature. This one also having the feature. This one is also having feature. This one is also having feature. These are data points. A new data point, that is tomato, has been introduced. It is also having the same features. Crunchiness we should have and sweetness also we should have. So what are those values? We will be saying 6 and 4, something like that we will be having. We will be finding out the distance between each and every data point. Each and every data point, we will be finding the distance. Among these, if we are considering k is equal to 1, in that case, whichever the shortest one, maybe it is shortest one, maybe it is the shortest one, maybe it is the shortest one. Whichever the shortest one, we'll simply considering that. Based on that, we'll simply say that it belongs to vegetable. If it is the shortest one. If it is shortest one, in that case, I'll simply say it is a fruit. When k is equal to 1. K is equal to, again, we'll be finding out the two shortest one among those. If both are same class, in that case, it will automatically become that class. If not, both are various different classes will be among those, which is the shortest one we will be taking. I hope it is clear. Locating the tomato nearest neighbor requires a distance function or a formula that measures the similarity between the two instances. There are many different ways to calculate distance. Traditionally, the Canadian algorithm uses Euclidean distance that we are talking about, right? That distance only it will be taking. So this is the formula when it comes to Euclidean distance. And we have seen, see, this is the sweetness and crunchiness. Sweetness, the features are 6 and 4. And crunchiness is 4. Based on that, we have to find out the distance between each and every point, and we have to come with which class it belongs to. So how we will be finding out 6 and 4, right? Let's give you briefly. So it is a tomato, right? Yeah. Sweetness is 4, crunchiness is 6. Let's consider this. Now what we will be doing? X2 minus x1 whole square, y2 minus 4 minus 10. 4 minus 10, sorry. 4 minus 10 whole square plus 6 minus 9 whole square. So it is one distance. So here how much distance will be getting? 6 square, 4 minus 10 minus 6 square plus 3 square. Under root will be having it 36 plus 6 is 36 plus 9. So how much will be having? 45. So how much the value is? 749, 6.5, something like that will be having. 36, yeah, similar to that we'll be having. Again, we'll be finding out the distance between this and this. In that case, how much we'll be getting? 4 minus 1 whole square plus 6 minus 4 whole square. How much it is? 3 square plus 2 square. 3 square and 2 square. Under root. So 9 plus 4. How much it is? 13. Root square of 13. 9 means 3 point something will be having. 3.5 something like that. Like that, we will be calculating for each and everything. K is equal to 1. Let's say it is the least distance. In that case, we'll simply calculate as K is equal to that tomato is the protein. But we have to find out the distance with each and everything. So based on that, whichever the shortest one we will be having, when K is equal to 1, we'll simply consider that. So here again you have to find out 4 minus 10 whole square plus 6 minus 10 whole square. 4 minus 7 whole square, in that case 6 minus 4 whole square. We will be having the some value, y value, some z value. Among these, which are the shortest one, when is equal to k is equal to 1, we'll simply consider that as the output. Like that, we'll be deciding which class it belongs to. So advantages. So let's I mean, as we discussed, it will be used for both regression as well as classification. Advantages of using the KNN: no training phase. So we don't need to do much of training since we just, I mean, basic calculations we are doing based on the distance only. We are not applying anything intelligence, just based on the distance. We'll be finding out the similarity based on that. Anyway, even though it is a very simple algorithm we'll be using, very effectively it will be doing the classification. It can learn complex models very easily. So not much of we are doing, just simple calculation we are doing, right, the distance. So in that case, we can easily able to implement it. It is robust to noisy training data. When you have a noisy data, in that case, it will perform better. Disadvantage of using algorithm: determining the value of the parameter k can be difficult, as different k values can give different values. So it is one of the concern. Anyway, that we can able to resolve using the k, and then that variance and bias trade-off graph will be hybrid. Using that, we can able to find out what could be the k value. It is hard to apply on high dimensional data. See, when you have just two features, x1 and x2, in that case, we can easily able to find out, figure it out. But if you have 10 features, 10 features means 10 inputs if you have. In that case, how can we able to? So it will become complex. In that case, so much computations will be involved. Each and every time you have to find out the distance between 10 features. So it will become computationally expensive. If so much computation is involved, in that case, it will become expensive model. So that is one thing we have to consider. Computation cost is high. For each query, it has to go through all the records, which take time, as well as it is the number of records. When you have multi-dimensional data, in that case, it will become computationally expensive, because it should consider all the features. So let's say one use case scenario, guys. So here we'll be using one use case scenario using KNN as a comparative tool for the price optimization in insurance. Like we have discussed, we can do the regression as well. Here we'll be doing the regression. What could be the price of the insurance based on the few features we have considered: age, we have considered sex, and we'll be considering the body to mass index ratio, and whether it is children and that particular person has a smoking habit or not, region. So we have seen right at the very beginning which region he belongs to. That is also one feature. What is important? One of the important feature to decide how much you have to charge. See, the charge is completely depend on risk. Let's say central region people, we won't be having any calamities when it comes to central region compared to the northeast. So northeast, especially Assam and some other areas, we will be having the harsh climate, right? And floods, all those will come up. In that case, risk to people's life is more. In that case, the probability, probability for that particular person, life, risk of that life, in that case, increases. In that case, we need to we have to increase the charges. So we'll be considering all those things. So southeast or southwest, these will become very important feature. So you can see here, southwest, it is having the high charges compared to the southeast. Southeast, this much. When it comes to northwest, here it is increasing again. Northwest, it is decreasing again. So it is depends on it is important region, which region that particular person belong to. It is one of the important feature will be having. And a smoker, whether that particular person smoker or not, this is also one important feature. If that particular person is smoker, in that case, we might have some health issues. We might get health issues way earlier compared to the person who will be who doesn't have any smoking habits. So this is also an important feature to. So I mean, what exactly we are looking into? If person having the probability getting sick, or getting into something that is dangerous. So in that case, we have to, he might be claiming that insurance, whatever the payment he is doing, he will definitely claim the insurance. So in order to, decrease the burden on that particular, company, we will be considering all these features because we have to pay them back, right? So yeah, male, female, it is also an important feature, male or female, that is also one thing. And age, if age is high, in that case, that particular person might having the health issues much sooner compared to the engaged people. So that is also one of the important features that we have to consider when comes to charges, how much we are supposed to charge to that particular person. So this is the use case we will be having. And so these are the exploratory data analysis. We will be doing that in program. We'll be executing all those things. You can see EDA, exploratory data analysis. Same, what are the features we'll be having when you use insurance.head. In that case, you will be getting all these non-smoker or smoker, non-smoker, smoker, which region it is, how much charge they are doing, age, whether it is male or female, or how much is the body to mass index ratio. If it is having the body to mass index ratio is high, in that case, we'll be having the fat. If you are having the fat, in that case, you'll be having high probability to get sick compared to the people who are having the less body to mass index ratio. So these are all important features in order to decide how much charge we have to give. So description. When you are doing the description, in that case, we will come to know what is the minimum value we will be having in that, what is the maximum value we will be having, how much data is present in 25% ratio data, quartile you can say 50% data on 75% data, and what is the maximum values. Based on that, we can go with whether we should go with the normalization or not. So you can see here, minimum value is how much? 18 and 15.9. When it comes to age is minimum 18 we are taking. So less than 18 we are taking, for them you will be having separate insurance. So we will be going with fully grown adults. And what is the maximum age we are considering here? Minimum is 18 and maximum age is 64. So if we are that particular person is beyond 64, in that case, some other life insurance policies will be applying. So this is for fully grown adults. And BMI, what is the BMI? We are considering minimum is 15.96 and maximum we will be going with 53. Okay, that is high. Okay, children's, for them, what is the minimum age? And what is the maximum? It is for separate, we'll be having separate category, we'll be having how much we are charging. What is the minimum insurance charge we are doing? What is the maximum insurance charge we'll be having? So that policies are ranges from this range. And in order to look into count, sex, how many people are there we'll be having, how many unique values we'll be having, just male and female only we are considering. When it comes to smoker, how many unique values we have? Just 2. That is smoker and non-smoker. And when it comes to regions, we have taken the 4 frequencies, how many number of times we have that male, non-smoker, how many number of times we have, southeast, how many number of times we have. So this data we will be having in description. So these are all important features to select to finalize whether we are having any. So these are the region wise. If you have any outliers in our data, so you can see southeast or southwest, southwest and southeast, northwest and northeast. This data and their respective distribution of insurance cost by the smoking status. So these are all things we will try to do. These are the EDAs. Whether we have what kind of correlation we'll be having between each feature. Smoker is yes, and smoking into age. How what kind of relations we'll be having? Female and BMI. What kind of relations we'll be having? You can see here. The dark blue represent not good correlation, and when it comes to light, it becomes having the good correlation. Maximum correlation will be having 0.79 with what? Charges and smoker. If that particular person is a smoker, in that case, charges of the smoking is increasing, because it is a very obvious, right? If the person is smoker, in that case, he might be getting illness, kind of cancer also you can get if you do this smoking. So there is a chance you might get into the cancer. In that case, insurance company should pay high amount if he or she will be diagnosed with that particular illness. So it is a very important factor. That is the reason charges of person who is doing the smoking will be high compared to other people. So like that we have various this correlation in between the each and every feature. So when you go through that, in this kind of inferences you'll be getting. And this is the final model building we'll be having, and inferences. Predicted with respect to predicted cost when it comes to northeast, predicted cost when it comes to, so it is northwest and it is the northeast, and when it comes to this is northwest probably and the northeast. So southwest and southeast and the northwest and northeast. So these are the we are considering each and every data separately, west data, southeast data, because whatever the conditions we'll be having, it is very different. So that is the reason we have done that regression individually. And you can see the respected score, adjusted R square and RMSE that will be evaluation for the evaluation we'll be using that 71%, and here we have 88%, and RMSE value is a bit higher. And here R square value we got about 65. That will be deciding factor when it comes to the regression. And how much RMSE value will be having here, 88%, and RMSE value how much we are getting. So it is a very base model, and if you want to improve that model, you can do it. We'll see how we will be doing when it comes to programming. A business objective, predicting the future insurance claim amount and identify factors that led to higher healthcare cost. So we are simply predicting how much insurance cost will be there. So based on the third person, region, and the health conditions. So minimum. So what is the business constraint when it comes to this data? Is minimum data we have. Barely how much data will be having? 1338 records only will be having. So if we have a good number of records, in that case, we might come up with the better model. So data overview, these are the features, in order to proceed with that, we have some libraries, the basic libraries we have to install. So one of those is NumPy. We have pandas. NumPy is whatever the mathematical operations we will be doing, all will be present with NumPy. And we have pandas in order to do the manipulations. In order to do the manipulations, we will be using the pandas library. And then we have manipulation in data. Kind of, if you want to change any column names and the various other manipulations we can do using the pandas library, or importing the data set into the importing the data set. For that also we'll be using the pandas. And then we have matplotlib. So that for the visualization, unlike similar to that, we have plotly, express, and plotly graph objects will be having. This all comes under visualizations. And then we have PCA if you are going with the dimension reduction techniques. So we have more number of features. In that case, we can compress the data, or you can reduce the dimensions and you can visualize the data. And since we are going with the not classification, we are going with the regression, like we have discussed. KNN is also used for the regression. I'm going with the KNN regressor, since whatever the prediction that we are doing, it is a continuous data, right? Continuous. How much is the cost of insurance? So in that case, we will be getting the continuous data as an output. So I will be going with the k nearest regression, and with that we will be testing various other regression techniques as well. Among those, whichever the giving good results, we will go with that particular. And in order to evaluate that particular model, so gradient boost algorithm, I'm going with the SVR regression. And in order to do with that, it is supervised, so we have to split the data into train, test, and using the randomized. So we don't need to, so that we can avoid the bias data. And R2 square, when it comes to evaluation, we will be using the R2 square and mean square error, how much error we are getting. So these all libraries we need to have, we have to install it first. So we are installing. So simply run it. So I've already run it, and so at the end, it will be taking so much time to come up with this result. So I have already run it. If you want to, you can simply go through it. Just run it. So all the data that all the libraries that will be having it are imported, and I'm importing the data set. In order to import the data set, so which data I'm using? Insurance prices. And we will be using the head function. We'll be using head function to see the sample of data. Very first 5 entries will be having it, that you can able to see. Age data we will be having, sex data will be having, BMI, and children, and smoker, whether that particular person smoker or not, a region, and how much charges. So it is the output, right? Target variable. It is our target variable. When you have, this is label data, that is the label data we are talking about. When you have a label data that is in the continuous form, which one will be using? Regressor. That is the reason we are using the KNN regressor. And here you can see INS head. If you go with the head, in that case, the first 5 data points will be shown. And when it comes to some describe, in order to do the description, it will simply show you what is the minimum value, what is the maximum value that we have seen just a few minutes ago. And here, summary statistics for categorical columns. If you have a categorical columns, what kind of unique values you have? Sex, we have just 2 unique values we have taken, that is male and female. Smoker, we just have 2, that is smoker and non-smoker. Region, we have taken the 4. So among these, which is having the top? Male we have maximum, and non-smoker people will be having maximum, and southeast people having the maximum insurances. Number of policyholders, if you want to go through individually, how many people we have in male. So these are the exploratory data analysis, so that you can understand better, and if you have a balanced data or not, to decide that also we can go with the average claim. So number of policyholders, how many we have? When it comes to male, 676, and female 662. Average claim amount, how much they have claimed. So pretty much similar we'll be having. It is about $14,000 they have claimed, and when it comes to females, they have claimed about 12,600. A variable smokers, non-smoker, how much claim that they have done. You can see here, non-smoker people have claimed very less. So if you are deciding the charges when it comes to insurance, you can go with the non-smoker people are little less. Why? Because there are, when it comes to illness, they will also get illness, but compared to the smokers, will be having less cases. Here, smokers are getting more number of cases, and the claiming is also too much. So that is the reason when you see the data frame, they are charging too much. And when it comes to correlations also, we have seen, right? When the person is a smoker, in that case, they are charging the maximum amount. And here you can see variable regions will be having number of policyholders and average claims. Southeast, various region, how much people will be having. You can see the guys, the number of data will be having, it is a balanced one. So make sure you have the balanced one in order to avoid the biased result. So how much claim they have done? Yeah, pretty much same claims we have when it comes to each and every region. Other than the smoker and non-smoker, we haven't found anything, something very shocking. Non-smoker and smoker, that is the only thing that we have that we should specially consider, and other than that, we have pretty much none. And distribution of the insurance cost by region. So how much distribution will be having, how much cost we and we are taking from the individual regions. It is a box plot, and with respect to the box plot, you can see what is a quantile 1. We have how much we are charging, quantile 2, how much we are charging, quantile 3, how much we are charging, how much outlier data will be having in this. So whatever the outliers will be having, in that case, we might we have to do the pre-processing. So that we also will be doing. And when it comes to smoker and non-smoker, how a distribution of the insurance cost by smoking status, you can see it is a dark red. In that case, it is smoker, and if it is not, in that case, non-smoker. And the distribution when it comes to cost insurance, you can see for this we'll be having a little bit of, it is not exactly the normal distribution. As similar, good distribution will be having when it comes to smoker. You can see this is a distribution when it comes to respected data. Average insurance cost, by age and smoking status. So average insurance cost by age, and when you have age in between 18 to 28, when you have a smoker, how much insurance costing you, and when it is non-smoker, you can see here huge difference you can find out in between this and this. The huge difference will be having, right? This kind of insights you will be getting when you get through the data, when you go through the data. This will be helpful for us when you are building the model. So when you are going with the model, this data will be helpful to bring out the best model among whatever the model that we are building. Among each group, insurance charges are significantly higher. These are the inferences, significantly higher on average in smoker than non-smoker. We also see higher claim amounts as age increases, with most expensive claims in the 16, because the people who are having the high age group, in that case, they might be the one who get ill very frequently. So in that case, the insurance claim when it comes to the higher age group, it is very high compared to other people. That is the reason, if you are when you are going for the insurance, if you are registered for the insurance, they will ask you age and whether you are smoking habits, whether you have any alcoholic or not. It is also a very important feature, alcoholic or not, smoker or not. Based on that, they will charge you the insurance money. So they won't consider all as just one category, and they won't give you whichever the age group, in between 80 to 60 age, if you have all, they won't charge the same amount based on the age group and the kind of habits you will be having. Based on that, they will be deciding how much charge they have to do for monthly or yearly charge. This completely depends on individual. It is not for the general. They won't generalize. It will be very individual. And when it comes to insurance cost, see, when you have body to mass index ratio, more body to mass index ratio, in that case, if you have more value, in that case, body fat you are having more. If it increasing the body to mass index ratio, in that case, increasing the body fat. If body fat is increasing, in that case, the probability of getting sick is more. When body to mass index ratio is increasing, fat is more, in that case, the probability become a sick is more. In that case, they will charge you but a much higher if you have a body to mass index ratio, you can see here the relationship table, that is scatter plot. Scatter plot. Scatter plot of it is a body to mass index ratio and how much they are charging. So you can see significant growth. Significant growth you can see if body to mass index ratio is less, in that case they are charging less. There are very less cases. Body to mass index ratio you have small, and if you have other habits, let's say you are a smoker. So these kind of inferences we will be getting as beautiful inferences. Let's say non-smoker and you have a body to mass index ratio. In that case, what we can say, you have you have very less probability to become a sick. So in that case, what they will be doing, they will be charging you less, charge for the insurance. Insurance charge will be very less compared to the people, even though they have a body to mass index ratio is less. And if you are a smoker, you can see these are dark, pink colors will be having it. These are all smokers. These are non-smokers. They will be charging you very less. This is the criteria. People who are having the less body to mass index ratio and they don't do the smoking. In that case, very less. We have under 10 to maximum $20K will be having. But when it comes to smokers and the body to mass index ratio is high, you can see this much value. You can go to up to $60,000. It is a huge difference we will be having. Insurance cost increase with the body mass index among the smokers. So many inferences we can draw using this data. So it is a So it is a scatter plot in between the amount as well as body to mass index ratio. Average insurance cost by the region, how much average cost it is having with respect to the region and smoking. So smoking status and the male and female also we have taken. So it is pretty much same. You can say claim amount with respect to the smoker. So female and the male also we are considering. So it is not much difference we'll be having, pretty much same this difference we'll be having. And smoker when it comes to northeast region and the northwest region and southwest region and the southwest, southeast and northwest and northeast will be having. You can simply find out the differences when it comes to smoker and non-smoker. So here very less when it comes to non-smoker and with respect to the region and male and. So here it is a region and the male and female, it is pretty much same we'll be having when it comes to claims. It is a data when it comes to non-smokers. So southwest, if it is non-smoker and the male and female, we have average is about 8,234, and when it comes to male, it is 7,000. When it comes to male and female, you can see guys, females are claiming more compared to the males. And here the smoker, that amount you can see how vast difference we have. It is 7,000 when it comes to smoker, $32,000, and when it comes to here female, 8,000. Here we have 31,000. You can see there is one more anomaly you can detect here. Smoker you can find most when it comes to male. That is the reason claims when it comes to smokers are high. When it comes to significantly low, smokers will be having when it comes to female. That is the reason we have less. And northeast region, northwest region, you can see that is the reason we have less claims when it comes to female and high claims when it comes to male. So that is with respect to region wise and correlation when it comes to list. So here you can see female and charges and the children, BMI, age with respect to correlation. What kind of correlation will be having? You can see we have already seen in the PPT as well. So charges when it comes to smoke arrays, in that case, high charges will be having. This is the one correlation we have found out among these all. It is the highest correlation we have. And we were going with various models. Among these, you can see each and every region I have considered as a different one. R-square value and adjusted R-square value, we got 80% when it comes to region southwest when you are applying the Canaan algorithm. Region southwest, and how much we have got? R-square value is equal to 91%. It is a good accuracy we are getting here. And R-square value, it is about 88, adjusted R-square value. So we'll be considering adjusted R-square value because it is most reliable compared to the R-square value. So here we have less value, but there is a scope that you can increase because we have considered the very limited features, right? So we can consider features that are whether that particular person is alcoholic or not, whether he has any other illness that are present illness will be having. So various other features we can consider and we can improve this model. So there is a huge scope increase in that model. So whatever the accuracy that we are getting based on the having features. So southeast, it is giving good accuracy and the adjusted R-square also is good. Region southeast, so like that we have considered various ones. Yeah, sorry about it. So these are the that R-square values we are getting with respect to the each region, and we are considering various other models as well. With respect to those models, we got what are the models we have considered here? Scale train test. We need to first convert those data into the test and train. Whatever the train data we will be having, using the train data, we will be training the models, and using the test data, we will be checking how good we are getting the R-square value and the RMSE value. I'm considering linear regression, KNN, SVM, and gradient boosting. With that respected R-square values we are getting. So we'll be simply plotting based on the region. So how good it is performing. You can see pretty good accuracy we got when it comes to here. Adjusted R-square is about 88, but RMSE values we can decrease, and we have some outliers as well because we haven't done pre-processing when it comes to outlier. That is the reason we got this much RMSE value. We can try to decrease that when you do the pre-processing. These values it can significantly it can decrease. Same here when it comes to the data adjusted R-square. We got 71. It is a reliable. That is the reason I'm considering only adjusted R-square instead of R-square. And here you can see the same case. If you do the outlier treatment, in that case, you can significantly decrease that RMSE value. And when it comes to our northeast region, it is not performing well. If we are including the more number of records in that case, it might give you the good accuracy. So there is a huge scope as we have discussed. And the KNN model produces better test error overall the linear. So among these, so you can see among the all the other models, KNN is performing better. So whatever the results we have taken, this output we have taken, it is the KNN results. Since it is performing better compared to the other algorithms, so have taken that as an output. Model summary: the KNN model produces better test error overall the linear regression, but explain less of observed variation, that is incidence cost across in the 4 regions. If you increase that data or records, in that case, we can able to improve the model. So these are the conclusions we'll be getting since we have less amount of data. In that case, the accuracy of the model also goes down. Since we are considering just 1300 data, so that is the reason the accuracy it is going down. But if you want to increase, in that case, you can go with the we can calculate other features as we can add other features as well. We can add these so many records, and we can able to. This is a base model, guys. If you want to improve, in that case, we can improve that model. So this is all about our KNN algorithm. So how KNN algorithm will be working, and what exactly that mathematics. Simple. KNN it is based on the Euclidean distance. So we are simply finding out the distance between those. Based on those distance only, we will be finalizing whether it belongs to which class. If it is having the shortest distance, in that case, we will be calling it as similar. If it is not having the shortest distance, in that case, we will be calling it as dissimilar. Like that, just based on the distance. It is the easiest among all the models we will be having when it comes to machine learning. KNN is the easiest algorithm, the simplest algorithm, because we are performing based on the distance only, and we'll be finding out the similarity. So this is all about the KNN algorithm, guys. I hope you guys have learned something, and if you want to continue with the series, in that case, you can continue, guys. In next class, we'll be coming up with one more use case, and with one more supervised algorithm, and we'll try to implement in the real-time scenario like we have did today, so that you can get a better understanding and how that particular algorithm is working. Obviously, we'll be going through that. And I hope you will be joining in the next session as well. And yeah, that is it for today, guys. And we'll see you with we'll see you in the next session with the new use case and the new algorithm. And until then, have a nice day, and we'll see you soon. Thank you.